Okay, this is a overview of Chapter 7, which is the different oceanic zones. Please follow along and double check your work. This chapter gives you a brief introduction on the different zones and what factors might affect those different zones, but you're going to go into a little bit more detail with your projects. So the different layers of the zone can be affected by these 6 main factors: light, temperature, salt or salinity, depth, latitude, and density. In Chapter 2, we looked a lot. We looked in more detail with density and how density changes throughout the depth. We looked at salinity and how salinity changes with the depth, and we looked at temperature and how temperature changes with depth. So we're going to talk about those factors a little bit again, but we're also going to bring in a couple other things such as light. So 2 factors that identify the ocean zones is the amount of light and the amount of nutrients that that zone gets. These 2 factors are going to have a profound impact on the aquatic life. It's very hard to have plants without sunlight. And then if you don't have plants, then that's going to really affect the rest of the food chain. So to summarize, plants need nutrients and sunlight. So those factors are going to affect how many plants there are, which will then affect the rest of the food chain. Nutrients and sunlight are going to depend on 2 factors: distance from the shore and the depth. So the nutrients, which when we say nutrients, we're going to typically think of nitrates and phosphates because those are the nutrients that plants need. Nitrates and phosphates are going to come mostly from the land. So an area of water that is really close to the shore is going to have typically high levels of nitrates and phosphates because it's coming directly from the shore. Second is the depth. If it's coming from the shore, the deeper you go, typically the less nitrates and phosphates you're going to see. Oceans are divided into 2 major zones. We could divide them vertically, or we can divide them in terms of horizontal distances from the shore. So we need to take both of those into consideration. Intertidal zone, this is the zone that is in between. Inter means between, so in between the tides. So at high tide, it's going to be completely covered by water. At low tide, it's going to be completely exposed by water. So it's really the part that you're going to go play in when you go to the beach. The neritic zone is the section that is just above the continental shelf. And the oceanic zone is the section that is over or past the continental shelf. So the oceanic zone are going to be much, much thicker or larger in depth. We can look at it in terms of light, photic versus aphotic. Photic means there's going to be light, which light will go down to about 200 meters in depth. Beyond that, there's not enough light to have photosynthesis be working properly, so you're not going to get photosynthetic organisms below the photic zone. The aphotic zone, A means without or not, so this is an area without light. And benthic. Benthic means bottom or the floor, so anything on the bottom of the ocean or the floor of the ocean is considered the benthic zone. So vertical divisions. To better understand the regions of the ocean, scientists had identified the water column by its depth. Although we're not going to define each layer in terms of depth by exactly how many meters there are, we can characterize them by how much light there is. So the photic zone, again, that is the area that has light. It's about 200 meters deep. In this area, we have a lot of photosynthetic organisms because there's enough light to produce the energy. Phytoplankton is a very common source of plants. It is tiny microscopic or tiny plants that float in the ocean. This plankton word here represents, technically means wandering. So these plants they can't swim, so they're going to go wherever the mercy of the current takes them. Aphotic zone then is an area where there is not enough light for photosynthesis, so there might be some light present at the top of the aphotic zone, but not enough to have photosynthesis occur. The aphotic zone consists of a vast majority of the ocean in terms of volume. but it's going to have a relatively small amount of aquatic life because, again, there's no plants. That's really a good base of the food chain. So if the main base of the food chain is not there, you're not going to have the rest of the organisms. And then in between the photic and the aphotic zone is considered the twilight zone because it looks like twilight. So just as the sun sets below the horizon, you can still see, but it is dark. That's called the twilight zone. So it's important to look at photic zone and aphotic zone because, again, it ties in with photosynthesis. Ocean zones can be defined by their depth, not necessarily by their length. So this is another way we can divide the zones. Pelagic means open. So this is an area in the ocean where it's, like it says, open. There is no ground to it. So the pelagic zones can be subdivided into neritic, which again means the area just above the continental shelf. So the continental shelf is a relatively flat part of the ocean. It does have a gentle slope downwards out to sea, but it's pretty close to flat, and it's also not very deep. Beyond that, the ocean really drops off into what's called a continental slope, but it gets really deep at that point, and that is considered the deep water oceanic zone. So these pelagic zones can be divided into 5 major categories. Epipelagic is the top one. Epi means on or above, so it's on the top of the ocean. It is where we have lots of sunlight, so we have lots of photosynthetic organisms living in this zone. There's going to be a fair amount of life teeming in this area because, again, we have a good base of the food zone or food chain. Just below that is the mesopelagic. Meso means middle, and again, pelagic means open, so this is the middle open layer. You may also see the term twilight, so this can also be called the twilight zone. So some light is penetrating this area, but there's not enough light for photosynthesis. Because there's very little photosynthesis, there's going to be very little oxygen. There's no plants to produce the oxygen. There are still organisms in that zone that are that go through cellular respiration and take the oxygen out of the out of the water. So oxygen is being taken out and carbon dioxide is being put in. So oxygen levels are low and carbon dioxide levels are high in the twilight zone. Just below that is the bathopelagic. It can also be called the midnight zone because, again, it's getting darker as you go farther down. This zone covers the continental slope, where the continental slope is really the edge of the continental plate and the beginning of the oceanic plate. So it's still technically part of the continental plate, but the slope rapidly increases in depth. Therefore, the temperature is going to get dark and dark as you go farther down. Since we're below the area where we have no photosynthesis, there's not going to be any plants in this zone, so organisms have to find an alternate food. Most organisms in this zone can consume detritus, which is dead organisms that are sinking to the bottom of the ocean. So oftentimes they will really just float in the ocean. They will have eyes sometimes on the top of their head that are really large to try to detect any kind of movement. And they just sit there and just wait for something to sink by, and they will snatch it up and eat it. A common term for detritus is marine snow. If ever you've looked or watched a video of a deep ocean, you'll see white stuff floating in front of the camera. What you're looking at is detritus. That's dead organisms that are slowly sinking down to the bottom of the ocean. Okay, the next layer down is the abyssal pelagic. Abyssal is a word coming from a Greek word meaning bottomless. It was once thought that the ocean had no bottom until they lowered cables and they finally realized that yes, in fact, there was a bottom. But this is where the word originally came from. There was no bottom. This zone is completely dark. The base of the food chain in this zone is through chemosynthetic organisms. These are organisms that live in the hydrothermal vents and produce energy through the chemicals coming out. So a hydrothermal vent. Hydro means water, and therm means heat. So this is an area where there's magma somewhat close to the surface. This magma near the surface is going to heat the groundwater in the ocean floor. That groundwater is going to get hot. It has a lower density, therefore it rises up to the bottom of the ocean or the surface of the floor, and it will come out into the ocean. Some interesting things about this, if you look at the temperature, it is extremely hot coming out, but the area right next to it, we're looking at 2 degrees Celsius. Sometimes it actually gets below freezing here. Sometimes it might get 2 to 4 degrees below freezing. So we have extreme temperature differences. So organisms here must either learn to live in extreme cold temperatures or in extreme hot temperatures. Okay, so this hot water is traveling through the ground, through the crust. Hot water can dissolve a lot of solids much easier. So as it's traveling through the ground, it's going to dissolve all these solids, and then when it comes up into the freezing cold water temperatures, those solids precipitate out and form a solid, and this will then create what's called chimneys. These chimneys were once discovered, and no life was ever thought to be near these because of the extreme cold and the extreme hot temperatures. There's no light. But what they found are almost like rainforest of life teeming by these hydrothermal vents. The reason for that is the chemosynthetic organisms. Chemo stands for chemical. Synthetic means to make. So organisms are making energy through the fumes that are coming out of these hydrothermal vents. Next up is hadopelagic. Hadal comes from the term Hades, or the underworld god. This is going to really be in deep oceanic trenches, so extremely deep and not too common. Next up, we have benthic zones. So these are areas that are on the floor. So we can have the sublittoral, superlittoral, sublittoral, intertidal zone. The superlittoral, this is the air that really only gets flooded if we have storm surges coming in, or high water, high tides, or just really extreme weather cases. So this might get submerged in water, but not too often. Intertidal zone, this is the area between high tide and low tide. So half the day it's covered in water, half the day it's exposed to the land. Below that is the sublittoral, so this is always submerged in water. This is going to be on the continental shelf. There's lots of light, so a lot of photosynthetic organisms live here. Bathal, which is the midnight zone, this is at the continental slope, so again, that ocean is dropping down. Beyond that, the abyssal zone, so this area is colder yet, it's deeper yet. And beyond that is the Hadal zone, again down in the trenches. So it's the deepest, the darkest, the coldest zone in the ocean. It has the highest pressure. So a lot of the information for the Bathal, Abyssal, Hadal is going to be very similar to the Bathal, Pelagic, Abyssal, Pelagic. The only difference, this is on the ground. Okay, there's 3 major factors that would affect organisms that live down in the deep ocean. The absence of light is challenging. The low temperatures and the extreme high pressures are all very challenging for organisms that live down deep in the ocean. So there's a lot of adaptations that are interesting that you'll learn throughout your projects. Okay, last, the horizontal divisions. The seabed is divided into zones described above, but the ocean itself is also divided horizontally by distance from the shore. So we have intertidal. This is the area between the high tide and low tide, so sometimes underwater, sometimes not. This zone is hard for organisms because it has the wave energy, the pounding of the waves, the energy of the waves, tides, currents. It's exposed to predators that might want to eat them from the land. The neritic zone, this starts at the low tide mark and gradually goes downward to the edge of the seaward on the side of the continental shelf. Some sunlight will penetrate the seabed in the neritic zone. And last, the oceanic zone, this is the rest of the ocean.